Welcome back everyone. We are now in our second video of the topic elasticity. Now for this discussion, we will focus on price elasticity of demand, its formula, and how we're going to use such in computing for our elasticity coefficient. Now, first, we'll have to review the general definition of elasticity. Elasticity is the degree of sensitivity of one variable to the change in another variable. So let's talk about variables. Let's say we have price. Price is a variable and quantity demanded is also a variable. And we know that according to the law of demand and even according to the law of supply, the price and the quantity demanded for demand or the price and the quantity supplied for supply have this kind of relationship. For the price and the quantity demanded, the relationship is inverse or indirect or negative. We know that whenever there is a decrease in the price, there will be an increase in the quantity demanded or vice versa, assuming that all the other factors are constant. The question is, by how much will the QD change? Because although it is established that they have an inverse relationship, but we are not yet certain as to how sensitive the quantity demanded is to the change in the price. There is a possibility that if the price decreases by 5%, the quantity demanded increases by 10%, or maybe 50%, or maybe just 3%, or maybe about 5% also. So this kind of sensitivity will be measured using elasticity. There are many different types of elasticity, which I have discussed already last time. We talked about the price elasticity of demand, price elasticity of supply, cross elasticity, and the income elasticity of demand. So as I have mentioned earlier, we'll focus on the price elasticity of demand. Now, the general formula is actually percentage change in one variable, the one that is dependent, let's say quantity, over the percentage change in the change of the other variable, which is the independent variable. In this case, if it's PED, it is price. Now, Q here specifically is quantity demanded. When we say percentage change, we're not just simply talking about the difference, since we're talking about change, the difference in the quantity or the difference in the price. We're talking about the percentage change in the quantity and in the price. Now, let's focus first on the change. This is represented by the delta sign. When you say change, it is the movement of your quantity demanded from one point to another point. So getting the difference of the old and the new quantity will help you find the change. Now to get the percentage change, you have an option to divide it by the original quantity and then multiply this by 100. But this one is for the point formula. And we will not be using the point formula. We are going to use the midpoint formula. So to do that, we will be getting the average of your new and your old quantity. So Q2 plus Q1 divided by 2. So that's the percentage change in quantity demanded. Now, how about for the percentage change in price? So still, to get the change, you have to get the difference of the new price and the old price. And if we are to use the point formula, we can just simply divide it by P sub 1, the original price, and multiply it by 100 to get the percentage change. But we are not going to do that because we will be using the midpoint or the arc formula. So once again, we have to get the average of your old and your new price. So to do that, P2 plus P1 divided by 2. This is our price elasticity of demand formula. Now please take note again. Please remember that this is the general format of the formula. If we're talking about the price elasticity of supply, then instead of Q here, QD, Instead of QD, it will just become QS. So QS2 minus QS1 divided by the average of your QS2 and 1. But the price will still be P2 minus P1, etc. If we're talking about the income elasticity of demand, okay, so YAD, instead, since income now is the independent variable instead of price, and then demand is affected with income, then we can keep this one, Q2 minus Q1, over the average of Q2 and Q1. However, at the bottom part, it will be percentage change in Q over the percentage change in the Y, or the income. So instead of P2 minus P1, it will be new income, Y2, minus the old income, and then divide it by the average of the new and the old income. Okay? So basically, once you're familiar with one of the formula, for sure, it will be easier for you to remember the rest of the formula for YED, XED for the cross elasticity of the supply, and then the um, price elasticity, cross elasticity of demand rather, and then the price elasticity of supply. So you're just simply going to change the different variables depending on what is involved. Okay, so let's move on. Let's say that you're, after computing for the price elasticity of demand, or let's say X, cross elasticity of demand, or income elasticity of demand, or price elasticity of supply, whatever that is, okay, PAS can be, or YED, okay, or XED, your answers can either be greater than 1, less than 1, equal to 1, infinite, or 0. Okay, now let's just focus on interpreting the PED. Although, again, the type of demand will still be the same all throughout. If your answer is greater than 1, even if it's just 1.01 or 1.1, your demand is elastic. So what does it mean to have an elastic demand? It means that the buyers, or the demand, is sensitive to the independent variable. So if we're talking about price elasticity of demand, the independent variable here is the price, right? Because as price increases, QD decreases. So price is the independent variable. So to have an elastic demand would mean that the demand is sensitive to the change in price. If your PED is less than 1, you have an inelastic demand, which means that the demand is not sensitive. Not that it's not like it's not responding, or but it's just that it is not that sensitive. It is somehow insensitive. Okay? And if the answer, or the PED, is equal to 1, then you have a unit elastic demand, which means to say that whatever change that takes place in your price in percentage form, that is also the percentage change in your demand. So for example, if the price increases by 20% and we expect QD to decrease, the decrease is also by 20%. But here in the elastic demand, if the price increases by 20%, the QD drops by, let's say, 25%. So it's very sensitive. In this kind of demand, in inelastic, if the price increases by 20%, the drop in your QD is small, let's say around 15%. So it's not that sensitive. It's responding, it's reacting, but the reaction is kind of weak. Then we also have an infinite, usually if you are to quantify this, usually big numbers like around 10, 15, 20, okay, which are very far from 1, we can already classify it as perfectly elastic demand. So it's just like elastic, the demand is sensitive. But It's not just sensitive, it's hypersensitive, overly sensitive. For example, there is a decrease in the price by 20%, the quantity demanded rose by 200%. Okay? Or let's say you just increase the price by 5% and then all of a sudden the quantity demanded dropped by 80%. Hypersensitive. Now, if your PED is equal to 0, or even if it's XED or YED, this type of demand is perfectly inelastic. Okay? So it's not just insensitive, it does not respond, the demand does not change at all. Okay? So it's like absolutely not affected by the change in the independent variable. Okay? So not sensitive at all. Example, you increase the price by 20% and diba we expect Q to go down, but the Q did not go down. It also did not go up. The Q remained as is. So the quantity demanded did not change following a change in the price. So even if the price did not increase, but if the price decreased, the Q still remained as is. So there is no zero change. So that is a perfectly inelastic demand. Let's have examples on how to apply our formula. Let's say that a business is selling a certain product at a price of 100 pesos. And with this price, about 1,000 pieces are sold. And let's say the management decided to reduce the price in the hope of selling more. So here, they were able to sell 1,200 pieces. Okay? So let us be reminded of the formula. The formula says there for the PED, it was Q2 minus Q1 over Q2 plus Q1 divided by 2. Okay? All over. First, P2 minus P1 over P2 plus P1 divided by 2. So we have four variables, P1, Q1, P2, Q2. Based on my example earlier, I said that the price was originally 100. So that is your P1. And at that price, they're able to sell 1,000 pieces. That's your QD1. And you change the price to 95. Okay? And the new quantity is 1,200. So let's see whether the demand is sensitive or not sensitive to the change in the price. So let's apply this formula. PED is equal to, let's make this bigger so that you can see it, and I'll change the color. So let's have the Q first. So the Q is 1,200, Q2 minus Q1, okay, all over 1,200 plus 1,000 divided by 2, okay, and then let's do the change in the P2. So P2 is 95 minus the old P, which is 100, all over 95 plus 100, okay, divided by 2 to get the average. Okay, so let us check. Maybe you can start computing now. And let's see the answer. Okay, so this is 1,200 minus 1,000. Obviously, that is 200. And then divided by the average of 1, 2, and 1,000 is 1,100 because 1, 2 plus 1,000, that's 2, 2 divided by 2, that's 1,100. And then we'll do the percentage change in P. So 95 minus 100, that's negative 5. And then we get the average of 95 and 100. The average is 97.5. 0.5. Okay, so let's try dividing 200 divided by 1100. The answer is 0.1818. Okay, it's actually 1818 all throughout, but I'll stop at 4 decimal places. And for the other one, 5 divided by 97.5 is 0.0513. I'll also stop at 3 decimal places. Now, we can divide the 2. So that is 0.1818 divided by 0.0513. Your answer is 3.54. Okay, but this is actually in a negative sign because this one, negative 5 divided by 97.5, is actually negative 0.0513. So your answer is negative 3.54. Let me just rewrite it here. Okay. However, please take note that when we are trying to interpret or identify the type of demand, we are not anymore concerned with the negative sign. The negative sign is simply telling us that there is an inverse or indirect relationship between the price and the quantity demanded. So whenever we're computing for the price elasticity of demand, it is very much normal to get a negative coefficient. Okay? So it doesn't mean anything other than they have a negative or inverse relationship. So that is already expected. And since we are trying to interpret this type of demand, we need to get the absolute value. So your PED is 3.54. Okay, we ignore the sign. And 3.54 is greater than 1, right? So this is an elastic demand, which means that the demand, the QD, is very sensitive to the change in the price. Okay, let's be more specific with that particular change. Take a look at this and this. Remember that when we were computing for PED, the numerator was the percentage change in Q and the denominator was the percentage change in P. So if you are to convert 0.1818 to a percentage, we multiply it by 100. The change actually in your Q is 18.18%. Okay, it's positive, so there is an increase in the Q by 18.18%. But by how much did the price change? The price only dropped by 5.13%. Okay, so see the reaction of your Q. A small change in price, a drop in the price by 5%, increased the Q by 18%. So it is sensitive. We're not saying that it is perfectly elastic. It's just elastic because 3.54 does not merit a perfect elastic demand. So it's not, it's high, but it's not that high. It's sensitive, but it's not really hypersensitive. Okay? So this is how we compute for our coefficient. Now, as we go back to our discussion about elasticity, price elasticity of demand, and revenue, okay, what is now the best pricing strategy for you in order to maximize or to increase your revenue, knowing that your demand is elastic? If they are sensitive to the price, okay, what do you think should you do with the price if you want to increase your total revenue? Total revenue is P times Q. Should you increase the P or should you decrease the P? Okay? Your goal is to increase your total revenue. Okay? Knowing that your demand is elastic. Okay? So based alone on what we just computed for today in this slide, it is best to decrease your price if you have an elastic demand. Just try to imagine this. If your demand is elastic and then you did not decrease the price, say you increase the price by 5% or 5.13% if we are to follow the percentage here. Instead of decreasing, we increase it by 5.13%. What do you think will happen? Of course, the quantity demanded will drop. But by how much? It will drop by 18.18%. Is this good? Of course not. Because even though you increase your price, but your Q decreased by a much larger percentage. So in the end, it's gonna pull down your total revenue. Okay? But we did not do that. Okay, in this example, this did not happen. What happened was there was a decrease in the price and the quantity increased by 18.18%, which is good because even though the price was decreased, but then Q was able to cover up for whatever decrease, for whatever reduction in the TR. Okay, this decrease in price contributed. So, in other words, Q was able to pull up the TR even though P decreased because the change or the increase in the Q was much was larger, was bigger. Okay, it's about 3 times fold. So that's how we make use of PED in making decisions or pricing decisions for a firm. So I hope that you find this topic useful. That's it for this video, and thank you so much.